Microservices, event-driven architectures have been a concept for quite some time. They have been evolving, and the addition or the nuance of an event-driven APIs are more of a recent conversation. This paper, while a little old, like 4 years old, does go into interesting details and tries to summarize the key aspects of it. So, if you intend to build scalable systems, real time systems, or have use cases where you want to have push based communication, stay tuned to this conversation. Couple of key operating principles, I think we should just talk about it. So, real time or near real time, and real time is a very thrown around word. I think most systems are near real time. These experiences are built with event driven architectures. Event driven architectures, second, are loosely coupled and extremely agile, and becoming event driven creates kind of an efficient system because you are not adding a lot of coupling to your system. You are having loosely coupled systems. There's less single point of failures, and systems are kind of following through kind of a push based setup. So this kind of helps you improve or reduce the latency. You don't have to refresh the UI and things like that, and you kind of the design and the network load and the throughput etc are all automatically optimized. Before we go there, let's just take a simple look at the different components of a synchronous API first microservice architecture. This is super simple. We have we have the first part here, which is the client and the consuming part. Second, you have the edge services or the API services. These could be like your typical layer 7 firewall, load balancers, CDN, gateways, API gateways, etc. And then you have usually you have two of these kind of services. First is some kind of an integration service, and then you have the core services, which are more granular and atomic services, and below this you have databases etc, which are represented here. Now all of these communications are typically REST based, and internal service calls, which is between integration and atomic services, they are usually gRPC based. You can have them REST based as well, depending on the familiarity and the kind of computational requirements you have. gRPC does have some benefits. We are not going to talk about that in this video, but it's kind of beneficial. But what do you do in this design when, let's say, you have to communicate upward certain changes in the system, let's say prices or anything like that? So whenever you have this kind of an example, right, where there are event consumers, things like web application for an e-commerce, point of sale mobile app, where you have to constantly keep on pushing availability of stock. Let's say that on Amazon you're buying a product and somebody is buying the stock units at hand, pricing changes, discounts, events etc are kind of pushed through, right? And these are typically created by event producers, which are part of the backend system. It could be inventory management, databases, finance, tons of different services. So usually what developers would do is introduce some sort of a polling logic, and that's the kind of design that it kind of works fine. However, it does incorporate a little bit of bad behavior in the system. Your polling logic kind of takes a toll in the system etc. So a much more better approach is to have some kind of an event driven API first microservice. And what you typically see here is, right, in addition there's a messaging layer, and this messaging layer, depending on the kind of computational environment you are in, could be Kafka, NAT, RabbitMQ. For much lower devices you can have PubSub, MQTT protocol etc etc. And you can have also enterprise service bus attached to it, and then you have the bottom atomic services, and on top event driven services like the API gateway etc etc. So typically there are a couple of approaches and to this kind of a design, and let's go through what are the different approaches to event driven APIs. There's few options listed here in blue or highlighted. There's WS eventing, which was for SOAP services, XMPP, which is a polling based protocol, which is similar to a socket, but was kind of older uh, protocol. It says web WhatsApp is still based on XMPP at the time of this writing. I'm not sure if WhatsApp still does that. It's kind of a bidirectional communication, but more advanced version or more recent versions are gRPC, which can be actually bidirectional. You can have WebSockets, you can have MQTTs, you can have server sent events, you can have webhooks, etc. And that's what we'll go into looking at this. So the first one in the list is webhook, which kind of is a reverse API. So what happens is that when a consuming application makes an API call, there's an acknowledgement sent, and at the same time there's a kind of subscription sent to the broker, and the broker has a component attached to it which is callback component, and whenever the processing is complete, the callback component makes a post call to the endpoint or the callback URL that the consuming application has. The consuming application will always need to be some kind of a server, because it will need to host that post method so that the endpoint is available. So this kind of works. This is a pretty good design, but for large volume requests this kind of design might not be good. Also, if you want to push like directly to client application, let's say browsers or mobile apps, this kind of approach will not work. This approach is very nicely suited if you're trying to build, let's say, a payment application and you want to get some kind of a payment confirmation, etc. So that's webhook. Then you have WebSockets, which are very straightforward bidirectional communication between the server and the client. You have a point-to-point TCP connections, and there's no pub sub or anything, but it's just a direct form of communication. There's no request response strategy required here because the communication is opened. However, there's good and bad associated with this. Some people would believe that this poses some kind of a security risk also. However, WebSockets are very largely implemented in places. Server send events are kind of subscribe only protocol. These are great for lightweight event deliveries, and you would see them implemented along a lot of times when you are delivering something to a UI in a React app or not. Then you have GraphQL. You have GraphQL based queries, GraphQL subscriptions, GraphQL live queries. This is what I say, GraphQL queries, gRPC, which is a polling method, and then you kind of move to the event enabling API management. So how do you manage the API along these parts? There's different components that you would want to design within your setup. So things like security, analytics, developer portal, throttling, etc., you will want to add in your system. So this paper, essentially, I'll put a link in the description. That's in essence what I wanted to talk about from a options perspective. So if you're designing event driven APIs, do take a look at these methods, techniques, etc., and they could be really useful if you're trying to scale up your system. All right, until next time, bye bye.